Hello everyone. Today in this video we are diving deep into mastering process management in Linux, a topic every Linux user and aspiring system administrator should know. Whether you are managing a personal server or aiming for professional DevOps roles, this is an essential knowledge. Let's get started. In Linux, a process is an instance of a running program. Every command you run in the terminal, like opening a text editor or compiling code, creates a process. Each process gets an unique PID or process ID, which helps the system and users manage it individually. And every process runs under a specific user and group, which defines what resources and files it can access, based on the Linux file permissions. Processes aren't static, they move between states. Let's break down the main process states, which are running, currently executing or ready to execute process. Waiting state. The process is paused until a resource or event is available. Stop state. Process halted by user or signal can be resumed. Just like when we press Ctrl C and any process running in our system stops immediately. Zombie state. Has completed but still has a PID because the parent has not cleaned it up yet. In Linux, processes are arranged in a hierarchy. A parent process creates one or more child processes using the fork system call. The child process inherits attributes from its parent, including environment variables and permissions. Even your terminal has a process ID, and everything you run from it becomes a child of the terminal process. Linux uses a scheduler inside the kernel to decide which process gets CPU time. The scheduler ensures responsiveness and efficient CPU usage, especially when multiple tasks are running. Linux supports several scheduling policies, just like FIFO, round robin, and fair scheduler. FIFO is first in, first out for real-time tasks. Round robin gives each process a time slice. Fair scheduler balances tasks for general use. Understanding this helps us control how aggressively or gently a process runs on the system. Now, let's look at how a process starts, changes, and ends. Process execution. Process execution has some steps, in which the first system call is fork. That creates a new child process that's a copy of the parent. Next, exec execute replaces the current process with a new program. Next system call exit, used when a process finishes. It returns status to the parent. This life cycle is the backbone of process control. Signals are like messages sent to a process, often to control it. Some common signals include sigterm, which is used to terminate a process. Sigkill forces the process to stop immediately, cannot be caught or ignored. Sigstop, it pauses a process. Processes can handle many signals by writing signal handlers in their code, except for signals like sigkill. You can use command like kill or kill all to send signal based on PID or name. Linux gives us tool to control how much of each resource a process can use. CPU. CPU uses nice and renice to control priority. Memory. Monitor RAM usage with top and free. Disk input-output. Manage read or write operations using I/O nice. Network. Limit bandwidth usage using tools like TC. These are the particular commands which are used for the particular uses. Now, to keep your system healthy, monitoring is the key. Use top or htop to see the real-time stats like CPU, memory, and process load. PS gives us a snapshot of processes at a moment. You can find hung or misbehaving processes and take corrective actions with tools like kill, strace, or LSOF. Here are the few expert tips. Best practices for process management. Automated tasks. Using cron jobs like restarting services or performing backups. Set resource limits. Using ulimit or control groups, which are also known as C groups. Log everything. Errors, process starts, crashes for future analysis. Regular audits. Check active processes and configurations frequently. Let's wrap up. Process management isn't just about killing raw process. It's about keeping your system fast, responsive, and stable. Leverage Linux's powerful commands like top, ps, nice, kill, and htop. Use scheduling and signals smartly. Set up proactive monitoring and automation to reduce downtime. Mastering this not only improves system health, it helps you become a more effective and reliable Linux user or admin. Thank you.